Hello, everybody. I think we can get started. Again, good morning. This is the DMTF representation, right? My name is Chandra Nelogal. I'm part of Dell Technologies, working in the infrastructure solution group, focusing on data storage and security. And I represent Dell in a few work groups. In TCG, I represent them at storage work group as a co-chair and at DICE. And in the DMTF, I participate in the PMCA work group, focusing on MCTP and other management technologies, as well as in the SPDM work group, where it is all security, right? So here, I'm kind of representing the DMTF SPDM work group and giving an overview of the SPDM 1.3, which was released back in the May of this year, and like a little bit some preview of the work that is in progress under the work group. So let me proceed. So this is standard DMTF disclaimer, and then threat model. So SPDM, why it is even here, why it was even conceived is essentially the threat model. So you can think of a conceptual platform diagram here. You have a memory compute complex, you have IO subsystem, they all deal with user data. Then you have other electronics that are essential for a platform, and there have been attacks, right? There have been counterfeit products. There have been malware inserted in embedded systems, and I think Eric might have covered some of them yesterday in one of his sessions. So essentially, it is all about device authenticity and attestation. That's where SPDM comes into play. So I'm not going to go into complete overview of SPDM, but just a brief preview for that. So overall goals of SPDM, right? So you have device attestation and authentication, and that includes hardware identity and measurements, and the whole protocol is really based on that. And then you have secure communication channel between what is a SPDM requester and a SPDM responder, and that covers that, right? It's really two main goals, and that is all in the protocol. Also, just one kind of a behind the scenes view is, although SPDM as a protocol defines what's going on the wire, and then there is MCTP binding or other bindings I'll talk about later, the underlying technology may be leveraged from other work groups or other documents, and SPDM really stays silent on that. It doesn't make any mandatory requirements. For example, you could say DICE may be the underlying technology of identity generation, and then affiliation of an identity to a hardware, and then SPDM conveys that evidence out of the device. You could say that, but SPDM as a specification doesn't call that out. With that, let me go on. So SPDM obviously has gained traction, right? So we have several organizations that we are all familiar with, the CXL, OCP, PCI SIG, and then TCG. In fact, TCG, we wrote a binding specification, and many of these organizations are adopting and have referred to the SPDM specification in their documents, and there is definitely one more that is work in progress. Again, they are all leveraging SPDM, and then even from the vendor community, we have seen a lot of adoptions. We have system integrators launching. We have component companies already supporting products, 1.0, 1.1, 1.2. So it is gaining traction. And it becomes more and more important as we get into distributed ecosystems, right? When you are talking about pooling, when you're talking about pooled resources, remote attestation becomes that much more important when you're admitting a component, admitting a platform into your cluster. So SPDM so far, right, up till 1.2. 1.2 was released in 2021, and I just give a brief overview of this, right? I don't want to go into a whole lot of details here. We have had several SNIA sessions on SPDM, right? I've done one and this is all virtual, right? Most of them have been virtual during the COVID and post-COVID timeframes. Other people have covered overview of SPDM. I've covered some of the certificate model in either SNIA SDC sessions or in the SNIA security summit. I think it was called the Storage Security Summit. We have covered some of those topics. So I don't want to go into a lot of the details of this, but essentially what you're seeing in the slide is the 1.0 was very bare minimum, sub 100-page document released in 2019 towards the end of it, and it really covered the device attestation and the certificate model, and then the measurements, how to retrieve measurements, how to sign measurements, how to do challenge response. That's what 1.0 covered, right? And it was very simple document to begin with. Then a little bit later, version 1.1 was released, wherein the support was added for secure sessions. And 1.2 did a fairly detailed amount of updates to the specification and added new functionality, wherein some of the highlighted things are in the bullet points there. Now you can get a CSR and install certificates, right? Then you can the alias certificate model. I have a slide that talks about alias certificate model, wherein mutable identities can be part of certificate chain, and dynamically generated certificate chains are feasible. So that is possible with 1.2. Then we have chunking mechanisms, really large payload on a limited buffer component. You can send and receive. Although SPDM 1.0 and 1.1 had a very rudimentary mechanism to do chunking, this becomes more formal and with a chunking command support. Additional algorithm supports OIDs. Again, the alias certificate, right? You have in the certificate chain, you have part of the chain that is static and then part of the chain that is mutable or dynamic, and being able to distinguish between them. The DMTF org defined a bunch of OIDs for specifically for that purpose. And then the mutual authentication in the challenge and challenge auth got deprecated. So these bullet points are some of the things I'll spend a little bit time covering. So we have eventing mechanism, we have multi-key support, and that leads to additional certificate model. I'll cover that. The new measurements, essentially it's policy. It helps with policy, can also be tied in with eventing. We'll cover that. And then measurement extension log, something like PCRs. Then there is a specific measurement type identified for structured manifest format. We'll touch upon that. And the endpoint info, which is really talking about PCI. So eventing, right? Eventing, really nothing new about eventing overall. It is the mechanism that we are all familiar with. You have you discover the event types that are available, then you subscribe to them, and then when that condition happens, you get notified about events, right? It's very simple, but it is defined in the SPDM specification 1.2, sorry, 1.3 I should say, in a secure session. I mean, really, as a mechanism, it is very simple, but it is defined as per the protocol. And the DMTF event types, really there are 3 or possibly 4 events. Really the measurement has changed, and then the measurement pre-change event, certificate updates have happened. These are the event types that are defined as of today, and then it is extensible. We should be able to define additional events later on, but those events are defined as of now, and that is part of the spec. and event notifications are acknowledged from the event receiver. And typically you have a SPDM requester, which is your BMC or an OS agent or any entity that is doing the verification functionality. It is subscribing to events, and event notifier is a SPDM responder device, which is typically your responder component, and that is generating the events. So multi-key. So previous to 1.3, we had a restriction wherein for a given algorithm, there was only provision for a key pair, and then typically your components supported one asymmetric algorithm for SPDM purposes, and they may even leverage for secure boot or image authentication, anything like that, and then you were restricted in terms of the functionality, right? So we couldn't do different keys for challenge and measurements. Signing of challenge, signing of measurements. We couldn't, if we installed a certificate chain, although 1.2 provided mechanisms to install a certificate chain, the leaf certificate key pair needed to be the same as what the manufacturer might have installed. So there were a lot of challenges with that constraints in the 1.2. So with 1.3, we added support for additional key pairs per asymmetric algorithm, really 8 key pairs up to. And now you kind of get around or get away from those constraints. And this enables generic certificate model, which is what I'm going to touch upon in this next slide. So the first two certificate chain that you see there are defined in 1.0 and 1.2 respectively. So 1.0 really defined the device certificate model, wherein the leaf certificate represented the hardware identity. The subject key was representative of a hardware identity of a component and terminated. The whole chain was static. And then 1.2 defined the mechanism of alias certificate. So I don't know if maybe people are familiar with DICE architecture or layered firmware implementations, wherein you have a hardware identity and there is a mechanism to derive the hardware identity, and then subsequently every subsequent layer of the firmware before it launches, you can do measurements, you can create identities using DICE mechanism, and those identities can be part of your dynamically generated certificate chain, right? That is alias certificate model, and that is made available with 1.2. But again, because of the key constraint, you could either have device certificate chain or alias certificate chain in the SPDM device or a responder, and couldn't do, there was not a flexibility to do additional certificate installation because you were constrained by that. And certificate installation, where do you see the use case, right? So the use case could be, you could have a system integrator, a value-added reseller, even an end customer, cloud service provider, like it could be a hospital chain, and you want to be able to authenticate the component and then install your own certificate onto the component, and then now you can trust the component and you can go forward. So that is now made feasible, one with the definition of the generic certificate chain where all those constraints are taken away, and also enabling the multi-key support. Now you can have a different key pair ID associated with the generic certificate chain in addition to the key pair ID that is associated with the certificate chain in slot 0, which could be your device cert or your alias cert. So you could have coexistence of different certificate chains in different certificate slots of the device. So that's one major feature for 1.3. So moving on, so new measurements. So we talked about events a little bit earlier. So this is a kind of piggybacks on the eventing mechanism, if you will, right? Or I would like to think about it like that. So you have new measurements. So if, let us say, let's take the use case wherein a SPDM requester subscribe to measurements related events, and then a firmware update happened, but maybe activation not yet happened, right, on a device, or activation might have even happened. So the device can generate an event related to measurement. It could be measurement pre-update event notification, and then the requester can come back and take a remedial or a, next step action wherein it can come back and say, okay, now retrieve measurements for the firmware that is yet to take an update, right? So you can come back and ask for the measurements of the firmware, and the device will send the firmware. Now you can make your decision, right? Now you can apply your policy. You can say, okay, I'm sitting in the management domain, I'm in the control plane, I'm in the security plane. Over in-band, over some CLI utility, some other software, a firmware update has been initiated. I'm unaware of it, but I got notified through an eventing mechanism. Now I can come back and get the measurements, and now I can do a pre-check saying that, okay, these measurements are agreeable to me because I have reference measurement values and they are okay, or I have locked on some other reference value, I am not okay. You can make those policy decisions and permit what can be done, what cannot be done, or at least alert. So you can take actions as per your use case. Right? That's the use case to tie in the eventing with new measurements retrieval question. Of course, this is time bound, right? You are only looking at pre-activation, but if you are activated, you just get the measurement of the current firmware. And we are talking about online activation for the most part. So measurement extension log and hash extended measurement. Again, one more feature introduced in 1.3. So measurement extension log, really I have an example diagram like one or two slides later on, we can cover that. So the measurement extension log is really emulating or very similar to the PCRs from TPM, wherein as the device initialization progresses, different measurements are captured and then added to the extension log, right? So that's what is happening with the extension log. And then the hash extended measurement is essentially calculating the hash value of each of those measurement as you progress, right? So it's one more way of sharing measurement, through the measurement mechanism. So historically we have had just the measurements, right? So we have had a mechanism wherein the firmwares either pre-update or currently running measurement values can be retrieved, can also be a request to be signed and retrieved, and you can verify with your reference. But then as the device is initializing, there was no mechanism to capture the different modules and different layers that got executed, and this mechanism brings that functionality into play. So this is just a ladder diagram. You do get measurements, the hash extended measurement value can be retrieved, and then you can get measurement extension log, and I have an example, and then you retrieve the extension log. Again, SPDM has standardized on the terminology requester responder, because typically it can be BMC, it can be OS agent, it can be any functionality that is a BIOS, it could be any function, any entity that is implementing the verifier function in the attestation architecture. So this is the example of a measurement extension log. All the yellow shaded item, and this is taken from the spec, right? So it's from the spec example. So yellow shaded items are your ROM or bootloader, pre-bootloader, ROM image, and there are some informational items, just the naming and stuff like that. There are digest, hardware configuration data, things like that, and those are different distinct measurements. If you had retrieved just the measurement with those index values, you would have gotten those measurement values, but then they are also added to the extension log, and they are calculated as part of the hash, wherein I'm retrieving hash of ROMs, right? All the components of a ROM. And then in the green shaded items are your mutable firmware. You can think of it like that. And then all the measurements of the mutable firmware can also be hashed up into a separate hash value, and then we can retrieve that, right? So that's essentially the function. And then, again, as a requester, you may be interested in learning about the different modules and the sequence of initialization of those modules in the device. Another one is the structured manifest format. So SPDM, although it provides for a mechanism to retrieve your measurements, and the measurements are all over the place, right? There is no standard set of measurements. There is no minimal set of measurements defined, because you could have a very simple component with a single measurement value, or you can have a component with 50 different measurement values, and they can be configuration values, they can be binaries, they can be naming, you can have so many things like that. And the index values are also not standardized. They're intentionally left as implementation specific in the SPDM specification. And also it provides a mechanism of retrieving a manifest. So you can retrieve a manifest from the device during as part of your SPDM transactions, and then refer to that manifest when you retrieve actual measurements. And you can do comparison, you can apply policy, you can do whatever decision making that you can do with that, right? So up until 1.2, we had the DMTF measurement type 4, which was just saying that, hey, this is a manifest, but then there was no structured manifest. It was just free-form manifest at that time. And in 1.3, we added type A, wherein it says, okay, it's a structured manifest format, but then the specification points you to other industry organizations that might have defined a manifest definition, and say, you can refer to the structured manifest format, and then there is a vendor field. You can look at the vendor field and then refer to the structured manifest format defined by that vendor organization. And vendor organization, it's not really like a company, it's more of a industry standards organization, right? It could be IETF, it could be TCG, it could be PCI-SIG, it could be any organization like that, wherein we just refer from the SPDM saying that, hey, you follow the reference manifest or the manifest as defined by this organization, and that is defined by a DMTF type A right now.
Chandra, who maintains that sort of designation as to the organization?
That is in the DMTF SPDM specification. So we have a list of the organizations and the designated vendor ID values. And that, again, I don't know the history of it, but I would think these IDs were assigned by DMTF all along.
Is that a list that changes frequently? Because if it is, and you've got to roll the spec every time you want to add somebody.
Yes, I don't think the list has changed in the recent exercise. It is fairly static, and the IDs are not just SPDM specific. If I remember correctly, they are IDs that are DMTF wide. It applies to PLDM, for example, right? Other specifications also. One more feature, last feature for 1.3 I'm going to cover. Again, 1.3, not just these features, right? There were some errata items, there were some document fixes, some other minor things that have gone into 1.3, but I'm just covering some of the important changes between 1.2 and 1.3. So just a caveat there. So this get endpoint info is, again, you can say, again, these are all depending upon the member companies and driving a need for information, right? So this is, hey, I'm sitting in a management or a control plane, I'm talking to components, I have no visibility what that component type is, right? I may have metadata in the certificate, I may learn about serial number or a manufacturer or a device type through my certificate parsing, but I have no direct correlation between my sideband based device identity information or device information I retrieve over SPDM to my PCI inventory in-band, right? So that could be your use case, and that is the use case we are trying to solve with saying that, hey, now I can do get endpoint info, wherein as a response data, we are sending back from the component the device, PCI device ID, vendor ID, class information. So the control plane or the management planes, like a BMC, could correlate that with PCI inventory and say, okay, this device is now, I have completed attestation, I have completed authentication, you can perform anything like that, and then go from there. So that's the last one in terms of the feature I'm covering. Don't know how much I've done in terms of time. So the next 3 slides, I'm going to talk about what is the work in progress right now with the SPDM workgroup. So this is SPDM over TCP/IP binding specification. So essentially, right, SPDM had binding for MCTP defined, and then MCTP had binding for SM bus or PCI VDM or some other transport like USB, but it was not really for a network-based protocol. And this is work in progress. We are working on binding specification for SPDMs to be able to encapsulate the SPDM payload. It could be request, response data, anything like that, over TCP IP protocol. Again, you should be able to do remote, right? So today, if you say how you do remote attestation, it is the SPDM traffic terminates between the responder and the requester, and the requester, once it has SPDM data, could be sharing that SPDM information over other interfaces. It could be over Redfish. There is a component integrity manifest that was defined by DMTF a while ago. So you can be sharing SPDM data over other interfaces, but there is no direct network binding till now. So this is work in progress, working on that. And do not know the timelines for ratification, but it's still work in progress. So the SPDM to storage, and this can be fairly interesting for this group. So for NVMe, again, I'm just going to go into a little bit of implementation side of it, right? So the NVMe devices already have sideband communication mechanism. You have SM bus or PCI VDM, and you could be doing SPDM directly over MCTP, just like you would do NVMe MI traffic, right? So that was there, and therefore there was no real need for that. But the SAS and SATA devices, the NVMe devices over Fabric don't have a sideband interface directly, and we needed a mechanism to encapsulate the SPDM requests and the SPDM responses over native storage protocols. So that is the scope of this effort, and it is again being worked. And it is very similar to the encapsulation mechanisms we have for security, right? So we have for TCG payloads, we do IF send, IF receive. You use trusted send receive for ATA. Security is send and security receive command for NVMe. Same thing for SCSI command set. So it's essentially a different protocol identifier encapsulating the SPDM request and the response data over native ATA, SCSI and NVMe OF command set, and being able to send that and receive the response data. Eventing mechanism, again, it's TBD. Since SAS and SATA devices are not initiators, you don't have eventing mechanism there, but other functionality should be there, yes.
So we've recently defined IFSend and IFReceive over Swordfish, so you should be able to do this over REST interface now too.
Okay.
If that gives you enough layers.
Oh, okay.
So that I guess gives you something similar to your TCP binding as well, right?
Yes. Okay, thanks.
Question about the supporting NVMe. That's specifically NVMe OF over Fabrics?
That's correct.
Okay, because you use MCTP over PCIe, right?
Yes, for NVMe devices, the rationale not to go there was we already have a sideband mechanism. If I can do NVMe MI over MCTP, I can do SPDM over MCTP. And that can be transport over SMBus or PCI VDM. So there was no need to bind SPDM traffic over admin command over MI over MCTP over SMBus, right? So there was no need for that encapsulation.
Okay. So can you tell us a little bit of what that would look like? Would it be using NVMe commands to transport SPDM?
Yes.
Or NVMe OF?
Yes.
Okay.
So it is NVMe security send and security receive commands with a different protocol identifier.
Got it. So, but you would only use that if it's a Fabrics connection. You would not use that. Would it work if it were a PCIe connection? Because the point is, you've got two different ways of doing this one thing for NVMe.
Yes.
Okay.
Yes. No, the binding was defined, right? So when we did the requirement, right? During the requirement, this is the scope that we have identified, right? And when we even did the agreement with NVMe, this is the scope that we did. So we have not really put in the requirement for NVMe native, SPDM over NVMe, right?
Okay, I'll have to see what it looks like then.
Yeah. Yeah, again, it is work in progress, right? The spec work is in progress right now. It's early stages. Right now. So,
Sorry, one more. Will Dell be bringing the security protocol number request in T10?
no, it was already done. The protocol identifier requests were already submitted to T10, and T10 allocated the protocol identifiers, and we are using them for these three command set. Yeah. So this is a new spec, and it is not even a spec yet, right? So we are still at the very early stages of PowerPoint, and it is work in progress right now, and it's very early preview for you guys. So as we are doing SPDM, right, we are getting into use cases wherein you have to have credentials, you have to be able to do some privileged operations. You need credential-based privilege operations. Like, kind of one use case I touched upon earlier was, hey, can you permit a firmware activation or not, right? So that can be your privileged operation, and you don't want any entity to be able to control that, right? So this is it kind of morphed. It started off as a additional functionality within SPDM, but then morphed into its own authorization specification because there are a lot of overlapping use cases between SPDM workgroup, the PMCI as a PLDM set of specification within the PMCI workgroup, and we are thinking it makes sense to carve it out as a separate specification. So this is authorization, right? This very early stages, PowerPoint level right now. Requirements have been more or less understood and locked down, but still working through some more details there. Basically, it provides a mechanism to specify a set of privileged operations and then assign credentials for it, and then perform those privileged operations, permit or not permit, things like that, right? And to be able to disown the device, right, or unknown the device. So you take ownership of the device by setting up credentials, and then you should be able to restrict or permit operations, and then you can get the device revert. Is my TCG brain goes to reverting mechanism. So revert back, and then you should be able to revert, right? So that's this specification. It is work in progress. We are jointly working between the SPDM work group as well as the PMCI work group. And PMCI, as you know, right, it covers a whole lot of things. We do MCTP, PLDM, so many binding and several other miscellaneous specs get dumped into the PMCI work group. So this is also a kind of a joint effort, but owned by SPDM work group.
So do you think this is going to land in 1.4 or 2.0?
No, it don't know the timelines, but it is going to be its own spec. It's going to be its own DSP number. So it is not directly affiliated with SPDM, although there may be some minimum spec dependency, minimum version dependency that may be called out here. Oh, sorry, the question was, will it be aligned with SPDM 1.2, oh sorry, 1.4? I think the answer is it may not be. Anything else? So again, this final. So one, obvious statement, SPDM is gaining traction. There is a lot of focus on component level attestation. You have push from zero trust initiatives. You have platforms looking at this more seriously. Different components have already productized and in the middle of being productized. So gain traction both in the industry as a product level, as well as other specifications in other work groups. And again, the kind of Eric and I, we were talking earlier. So we are looking at ISO ratification also, and the use cases and the whole overall specification scope is expanding. And we are, for 1.4, we are still early, right? We just released 1.3 this May, 1.4 maybe end of next year, do not know. But we are still not in the process of freezing the requirements or anything like that. So we are obviously, as any other industry organization group, looking for wider participation, input, and collaboration with everybody. I think that's pretty much it. This just is really MCTP diagram depicting all the different MCTP message types and all the physical transports and how the MCTP sits in the middle. So I just wanted to leave that in so that we can cover the SPDM traffic types as well. But with that, any other questions, any points? Yeah. Please go ahead.
So the event service, is that the first instance of asynchronous messages going from responder to requester?
Yes, the question is eventing the first asynchronous notification that is going on? Yes, from SPDM point of view, yes.
Do I need to consider how that works with the kind of the language bindings that exist when we kind of break that requester responder?
Yes, yes. The requester responder terminology, again, the SCSI language, right? There was always initiator target relationship, and then SPDM always had the requester responder relationship. But that's why if you look at our slide deck and the terminology, we have gone away from requester responder. We are talking about new terminology, event notifier, event receiver. So very neutralized terminology, if you will. But then your typical requester is the one that subscribes to the events, and typical SPDM responder is the one that will generate the event. But then once you have event subscription established, you are talking in terms of the event notifier or a generator and an event receiver. So the roles will flip, and there are other implications, right? There are timing implications, right? If you look at the timing parameters, many of the timing parameters have ways of measuring and ways of corrective action depending on whether you are a requester or responder, right? So if you look at very closely, there are some subtle differences between requester and responder. Now that the roles have flipped, we got to think about that. We have done some cleanup work for that. For example, if I send an event as a component, as a responder device, I send an event, I'm waiting for acknowledgement, and that acknowledgement, what am I timing, how am I timing? So those are subtle impacts, but you are absolutely right. The roles have reversed, and we got to be cognizant of that. Thanks.
So our friends at OCP are now somewhat interested in SPDM.
Mm-hmm.
My understanding is that they're probably going to focus on 1.2.
Yes.
And my question to you is, with the certificate changes that were introduced in 1.3, should they really be focusing on 1.3 as opposed to 1.2?
No, I would say no. So the question is, OCP seems to be trending or liking towards SPDM 1.2 version, and because the additional certificate chain being supported in 1.3, should they be looking at 1.3? I would say it is kind of orthogonal. Reason being, the generic certificate model, let me go back here. So the generic certificate model, really in the spec we make it very clear, there is no real constraint and there is no real correlation with the device other than the key pair ID that the device is using for the generic certificate, right? So there is really no relation. So this could very well be, the generic certificate could very well be produced by the device, or it could be installed by your cluster manager or your application. Anybody could be able to install a generic certificate model onto the component. So there is no real relationship between device identity and a generic certificate model other than the key ID, right? So the device certificate and the alias certificate models are indeed having strong connection or strong tie-in with the identities of the device or the identities of the firmware. And in the spec, we make it very clear that the certificate slot 0 shall only contain either the device certificate or a alias certificate chain. The generic certificate chain is not supported on slot 0, but on slots 1 through 7, any model, any certificate model works. So from to kind of coming back to the OCP question, I would say 1.2 is a good specification to kind of align to from a wider adoption. It's no, again, as we looked at the feature set for 1.3, again, my judgment, there is no fundamental feature set that is required for a full functional SPDM version, right? 1.2 is fairly fully defined, fully functional version, and 1.3 adds on additional capabilities. Yes, Joe?
how it is envisioned that the ecosystem will roll out. Are the features going to be driven by what the device can do? Is the feature going to be driven by what system makers need from the devices?
So,
I'm a little worried about system requirement explosion.
yes.
Different system makers want different things.
Yes, definitely we have seen that, right? Especially looking through the lens of OCP and hyperscalers, there are a lot more complex, I would say, or more stringent requirements being driven from the hyperscaler community, mainly because their management model is unique and different, right? So they may be more gated on the successful attestation for admission of a device or a component into the network, and it merges well with the zero trust architecture and mechanisms. So there may be more stringent. So depending on what it is, right? So the way we are capturing requirement, it's like any member company, any working group member company is driving requirements, and then we are adding capabilities to that as long as the requirement makes sense. We have the discussion, pros and cons, and then we go and make the capability part of the specification. But then most of the additional features have been added as optional requirements, right? And then between requester and responder, they need to negotiate. There's obviously negotiating mechanism to do capability exchange, wherein you can understand what you are capable of, and then you can align on the feature set. But most of the 1.3 requirements are optional, if you will. So yeah, I understand John's point that, hey, is there a explosion, or as the spec revision adds on functionality, will the requirements be exploding? I don't think so. I think it depends on the implementations, but then there are stringent requirements from certain subset of the market.
So it's my understanding that part of the work on 1.4 is going to deal with post-quantum crypto. And the reason I bring that up is we're already seeing hints of when this is going to be required. And are you aware of any sort of consideration that PQC could essentially drive the version of SPDM that has to be essentially implemented?
Exactly. So Eric's question very apt. So just for recording, right? So is 1.4 going to focus on PQC, right? Yes. So that is one of our, at least within the work group, we have been discussing, hey, what are our driving requirements for 1.4, right? We are not really yet there in terms of our focus area. We are mostly doing a lot of cleanup work, working on the other 3 specifications I talked about. So we have 1.4, very light work is happening at this time. But definitely verbally, we have talked about the quantum safe or post-quantum algorithms and alignment for that may be the driving factor for 1.4 release, because we don't see an imminent need to release 1.4 specification to the industry. And we know adoption rates are fairly slow. Depending on the subsystem you're in, sub-market you're in, adoptions varies. Different components are at different levels of support. Different system integrators are at different levels of support. Fully cognizant of that. Therefore, 1.4 could very well be anchored by PQC support. And this may be best case, I would say, end of calendar 24, release of the spec, but it could be delayed depending on how things progress. No, that is standard DMTF PowerPoint template I'm using. Again, I mean, again, this presentation was vetted by the DMTF TC, right? So, technical committee. So we did the presentation in the work group, sent it back to the TC, got, what is public, publicly can be shared. So we're sharing it in the SNIA forum.
So it's published now, we don't have to worry about the confidentiality.
Yeah, yeah,
You don't have to tell us that.
Yes, John.
So, one more, the SPDM for storage, is there a lift target for that? Because when I looked on the webpage, all I saw was a publication target.
When you say lift target, what do you mean?
Work in progress.
Work in progress, yes, we intend to, but again, there is some other spec work, cleanup work that is in progress right now, but we have definitely talked about releasing a work in progress versions for both the bindings, the TCP binding and the storage binding, but storage binding definitely intend to release it as a work in progress soon, but I don't know when.
But real soon now in the expectations.
Real soon now, TI.
Anything else? I think we may have been out of time, but thank you very much.